Hi, everybody. Today we're going to do part 3 of the uh, simplifying radical worksheet that I gave you that has the answers plus the problems initially given. So what I'm going to do is I'm going to share a screen first. Today we're going to look at the rational exponent part of this. So let's share a screen. So this screen in particular just goes through the exponent rules we saw earlier in the semester. And so, we multiply two things with the same base. We add the exponents. We have a power risen to a power. We get rid of those parentheses by multiplying the exponents. If we have two or more things inside a set of parentheses with an exponent outside, we can apply the exponent to all parts inside. 2 and 3 tend to go together in that you typically have exponents inside the parentheses. And if you have an exponent outside, you end up multiplying the two together as we simplify. If we divide two things by the same base, we write the base once and subtract numerator exponent minus denominator exponent. Similarly, like number 3 here, the exponent rule for if you have a quotient inside a set of parentheses means you can apply the exponent to the top and bottom separately. And again, if there are exponents in the top, when you move this exponent in, you're going to end up multiplying them like we do in property 2. The negative exponent rule comes in two parts. If you have x to the minus m, where that's a number less than 0, then we rewrite it as 1 over x to the m, dropping negative. If we have the negative exponent in the denominator, we move it up to the top and drop the negative. And then the last property is if x to the 0th rather equals 1, as long as x does not equal 0. Now these rules work for any kind of real number. Okay? Even fractions that are exponents. So really, we're just applying these rules like we did before. Before, though, we had integer numbers. So adding 2 and 3 together is a little bit more straightforward for some people than adding 1/2 and 3/4 together. Okay? So that really is the real issue here for most people. So what I want to do is now I want to go back to that worksheet that we had. So I'm going to share that. There it is. And so the last 4 questions here deal with rational exponents. In this problem, we have x to the 2/3 times x to the minus 3/4. We have the same base. So we're going to add the exponents together, x to the 2/3 plus a negative x to the 3/4. Finding the common denominator of 12 would be 8 over 12 plus a negative 9 over 12, which gives us x to the minus 1/12. Since we write our exponents in positive format, since that's an x to the negative exponent power, we'll write it as 1 over x to the positive exponent power of 1/12. Okay. In number 2, we have an exponent outside the set of parentheses. So again, just like always, we move the exponent in, apply it to all parts in the parentheses. If there are exponents already there inside the parentheses, we multiply with the exponent we're moving in. So that 4/9 we'll move in and apply to the 25. That's how we get 25 to the 4/9. The 4/9 gets moved in and is multiplied with the minus 3/5. And the neat thing about this, or the 3/9, I'm sorry, the neat thing about this is that the minus 3 and we'll cancel with part of the 9, leaving us with 3. So we multiply together, we'll have a minus 1 here. Minus 1 times 4 is minus 4. And we have a 5 and a 3 left over here, so that's going to be a 15. And then we have a y to the 4th. We apply that 4/9 to that. That's 4 over 1. 4 times 4 gives us 16. Over 1 times 9 gives us 9. So we end up with basically a 25 to the 4/9 times an x to the minus 4/15 times a y to the 16/9. Now this x has a negative exponent, so we're going to take it down to the denominator and write it as x to the 4/15 in the bottom. The other two parts, the 25 to the 4/9 and the y to the 16/9, those two stay in place. Okay. And then for 3, example 3 here, we have a 2x to the minus 2/5, and we have a y to the 5th in the numerator, In the denominator, we have a minus 8, and we have an x to the 9/8 and a y to the minus 3/2. So we'll apply our exponent rules, since we have for the x to the minus 2/5 over x to the 9/8. We have the same base. We'll write the base once and subtract the exponents. So it's going to be a minus 2/5 minus a 9/8. When we find the common denominator, that's going to be a 40. And we multiply the 2 by 8 to get 40 in the bottom. We had to multiply the 8 by the 5 with an 8. So we multiply 2, in other words, with an 8. Multiply the 8 with a 5 here. So that means we have to multiply the 9 with a 5. So that gives us this minus 16/40 minus 45/40, which gives us 61/40 negative. And then for the y's, we do the same idea. We have this y to the 5th in the top and a y to the minus 3/2 in the bottom. So that's going to be a y to the 5 minus negative 3/2. Now, just because the second exponent is negative doesn't mean you ignore the negative. That makes it a double negative then. So that becomes then a 5 plus a 3/2. Our common denominator would be 2. So I'd multiply the 1 underneath the 5 by 2 and the 5 here by 2, giving us 10/2 plus 3/2, or y to the 13/2. And then, like before, we'll move the x down because it has a negative exponent and write it as x to the 61/40 in the bottom. As far as the coefficients are concerned, the 2 and the minus 8, we can reduce that out right away. 2 over minus 8 reduces to be minus 1/4. So that's where the 1 comes in here that's not written, and the 4 underneath here, and the negative. And then the last one, we're multiplying two things together. First thing we look for is exponents outside the set of parentheses. We have an exponent here outside the set of parentheses. We'll move in, apply that 4/5 to the 8, apply the 4/5 to the x, and apply the 4/5 to the 2/3, y to the 2/3. Keeping in mind, we're going to multiply those exponents when we move it in. We multiply this 2/3 times 4/5, we get 8/15. Okay. The other set of parentheses doesn't have any exponent outside here, so we can just drop it. So that's where this 2x to the 4/9, y to the minus 7/5 come from. That's from the first set of parentheses. We just dropped them because there's no exponent to move in. So we'll group the coefficients together, the 2 and the 8 times 4/5. We'll group the base of x's rather together, x to the 4/9 times x to the 4/5. Finding the common denominator between those two and adding, we get 20/45 plus 36/45, which gives us 56/45. So you end up with an x to the 56/45 power. Grouping the y's together, we have this y to the minus 7/5 plus y to the 8/15. Finding the common denominator of 15, multiplying the top and bottom of this minus 7/5 by 3, gives us minus 21/15. Adding together, we get y to the minus 13/15. Since that's a negative exponent, we'll move it down to the denominator. I can't do much with this 8 to the 4/5. It's not a perfect fifth power. Okay, so I'm just going to keep it in that form. Hopefully this helps you out a little bit. Have a good day.